Okay. Hello, my name is Minghao and my partners are Jose Elizondo and Leonel Martinez. And we're going to be talking about our project, which is going to be a sort of leak detection in clean environments. And by clean environment, I mean sort of the rooms that you see that people have to suit up for. Like, for example, we have one here in the SEB that will be soon operating. People have to suit up to go into that environment to do work, or else their projects or research can be contaminated. And I'm just going to define a few terms really quick. For an environment to be clean, usually the environment has to contain a certain amount of particles per, say, meter cubed. And commonly, the clean rooms contain usually 10,000 particles per meter cubed. And just for comparison, a normal environment has, as you can see, about 35 million particle per meter cubed. So it's very important that for us to come up with a project so we can detect if there's a leakage in a clean environment so we can get that fixed. And most of these clean rooms are used for research. You know, chemists and electrical engineers and physicists, they use it for purposes such as solid state design and or project research. They do it in those environments so they don't have contamination from other unwanted atoms or molecules on their project, because any contamination at all, those projects can be ruined. And just for some comparison, like one atom can mess up a whole project. So we need to get a device that get that detection of the leakage right away. And the current technology on the detection is they use through an RGA, which is residual gas analysis. And this is a very complicated module. For a person to use this, they have to be trained first on how to use that program. And what this does is it takes the different types of gases through a chamber, and it goes through that RGA, which detects all the gases in that environment, and then it plots a spectrum of those gases in a computer where you can see the different graphs of the gases present at that environment. And this is a complicated sort of analysis. If you look at the thing required, you need a RGA module, which is very expensive in a way that if you do it, you have to buy that to put through the RGA so you can see the different gases. What we're trying to implement is we were trying to simplify everything down to so you can just see the leakage itself instead of all the gases mixed up in that chamber. And we were trying to reduce the RGA down to just seeing a single gas spectrum instead of the whole spectrum of gases. And we're trying to do this with helium. And by helium, we can do the detection if we ionize these gases. And once they are ionized, we can use a photoamplifier to amplify the helium so we can see where the heliums are coming from. And if there's a leak in that clean environment, we can detect that immediately instead of going through and looking at the whole spectrum of the gases in order to find that leakage. And the photoamplifier or photomultiplier pretty much takes a very small amount of light and amplify it to the point where you can see it with the human eye. This way, we don't have to go to the computer module to look at the spectrum of gases in order to find the gas leak. And the advantages of doing this is very simple. I mean, you can already see that program of RGA and the module that comes with it is very expensive, tens of thousands of dollars. And by our project, we can reduce this down by a lot. Also, there will be no training required to use that program because it will be very easily seen. If there's helium present, you know there's a leakage because the helium gas will be leaking through wherever the leak is. And by just seeing that light coming out from our module, from the photomultiplier, you know that there's a leak. Or if there's not a leak, then you won't see the light. And that's pretty much our product. Is there any questions? No? Thank you.